Bismillah Rahman Rahim. Hello everyone. Welcome back to the PL-300 exam preparation series where we are having a look at the second learning path, model the data. In this video, we are going to continue our discussion on the topic create calculated tables, and we are going to see another table function that is going to be the last table function that we are going to discuss. And I'm going to add two functions here which are in fact not table functions, but they are important from an exams perspective, and we are going to have a look at those functions as well because we could not find any topic which was relevant and could not find any other topic where these could be discussed. So I have just added these two functions as part of this particular video. So the last table function that we are going to have a look is the generate series. So let's go to the dax.guide website and see what this function is all about. So here we see the generate series table function, and its definition says that it returns a table with one column populated with sequential values from start to end. So this is a table function that is going to have just one column, and it would have sequential values from start to end. And if you look at the syntax, here it says that you have to specify a starting value, then an ending value, and then an incremental value. So there are situations where you want to generate a series, which we have seen as part of our elementary school algebra, that there is the concept of an arithmetic series. So you can specify the starting value of that series, then the ending value of that series, and then the incremental value of that series, and all of that is generated as a single column. So there are multiple use cases of this kind of a series, and you can use this as part of the what if parameters. So we are going to have a look once we are in the third learning path, that what are what if parameters and how at the back end this function is used. But let's now go to the DAX Power BI DAX environment and see how we can create a table using the generate series DAX function. So here we have created a table by the name table generate series, and here I have used the generate series DAX function, and I have passed the starting value as 1, the ending value as 10, and the incremental value as 1. And here you can see that a single column table has been generated which starts from 1 and then increments for every value by 1 and goes to 10. So this is a very simple function that can be used to create any series, arithmetic series here. So you can have different values for starting and ending, and obviously you can have different values for the increment as well, and you can also put decimal values here if you want. So we are going to have a look at this generate series function again once we talk about the what if parameters inside the third learning path. Next, we are going to have a look at two other functions which are not in fact table functions, but these functions are very important from a PL-300 exams perspective. And the first of this function is the rank x function. So remember, we had a look at the iterator functions, and I said that any function with an x at the end is an iterator function. So let's have a look at the definition of this rank x. So the definition says that it returns the rank of an expression evaluated in the current context in the list of values for the expression evaluated for each row in the specified table. So this definition looks a bit confusing, but it's not that confusing. So let's now have a look at the syntax of this, and let's have some clarity on what this rank x function does. So here you can see that we have two parameters. The first parameter is the table, and the second parameter is an expression. So the table is where you define the table, or through a table expression or through a table function that will be evaluated to calculate the rank, and the expression that is evaluated for each row of the table is defined here. So these are the two mandatory parameters for rank x, and then there are three optional parameters. So essentially you are defining a table, and then you are putting an expression which works in the row context. That means that it is computed for each record of the table, and it evaluates the expression on the basis of which you are going to have the ranking. So what is happening behind the scene is that the table and the expression are working to first create a lookup table, and then that lookup table is sorted in the descending order by default, and then the expression that you have mentioned here, that expression is worked for each record of the table and compared with the lookup table, and based on the position of the lookup table you are going to get a ranking. So if this is a bit overwhelming to digest at this point, there is no need to worry, because we are now going to go and have a look at this particular expression, which is the rank X. We are going to first have a look at the mandatory parameters, and then we are going to explore the 3 optional parameters. So let's go to the Power BI desktop environment. So here we have created a new table and we have given it the name table rank X, and like I mentioned that rank X is not a table function, it is an iterator function. So we will have to use it in a way where we can use an iterator. So what we have done here is that we are using the add columns function, and in the add column function we have specified a table. So we have already had a look at this table, which was discussed once we were discussing the summarize column function. So this is the table. So if you have a look at the output, so this is the table which is actually there, and we want to add a new column, a rank, which actually computes the rank. So this is the area which is about the rank X function. So remember I said that there are 2 parameters. So the first parameter is the table. So we want the table that we have here, the product brand and the cost, to be used as the table, and then we want that the cost should be the DAX expression that is evaluated for each record of this table, and then it is compared with this value and a rank is generated. So by default you have the lookup table which is created behind the scene that sorts the value of this cost column, and it sorts it in a descending value. So you will have the highest value here and you will have the lowest value here. So once this cost expression is computed for this first record, this value is searched for in this particular array of numbers, this sorted list or this sorted array of numbers, and then the position of this number. So here if it says 54, then it means that it is on the 54th number in the descending order. You can change the order if you want, but we are going to have a look at it in a bit, but the default sorting is the descending order. So this is how you compute the rank. Then for the next product brand, for this value is again compared, and this value is 83rd. So it means that this is the 83rd value in terms of the descending order. So this is the minimum requirement of the rank function to work. Now we are going to have a look at the 3 optional parameters, and we are going to have a look that in case where we have a lookup table where the lookup table is a bit different than the function that we need to evaluate. So let's now go and have a look at that particular scenario and look at the other 2 optional parameters of rank X as well. So for the other scenario, we have created a table lookup using the select columns expression. So what this expression is essentially doing, it is creating this lookup table. So we have this lookup table with 5 values, and now we want to compute an expression and compare it with this lookup table, and based on the value of that particular DAX expression, we will see that where that DAX expression is actually ranked. So let's say if I have the value which is greater than 10,000, then this is going to rank that particular record as 1. If the value is between 8,000 and 10,000, it is going to give a rank of 2. If the value is between 4,000 and 8,000, then it is going to get a rank of 3. And if the value is between 1,000 and 4,000, then the rank is going to be 4. And any value between 0 to 1,000 is going to get a rank of 5. So this is going to be our lookup table. This table is going to be our lookup table. And then we will have another expression. So we will have a third parameter which will actually compute the value that we want to compare with the values inside this lookup table. So now let's go and see that particular example. So now we have another table which I have named table rank x2, and we have kind of created the same scenario using the add columns function. So using this add column functionality, we have the same table, product, brand and cost, and now we want to compare the value of this cost with the lookup table. So remember, we have a lookup table with 5 records and we have 5 values, and I want to see that this lookup table, using this lookup table, where this value ranks, within the lookup table. So here again we have the rank x function, and now this is the table, this is the reference table, this is the lookup table, and this is the limit function, that this is the limit DAX expression that is defining the value inside the lookup table. So these two effectively make up my lookup table, and the function which is now the third parameter, now this value will be evaluated and compared with the values inside the lookup table. So I would come here, I would say that okay, this is my cost, just compare this cost with the values inside my lookup table. So remember, we had 10,000, 8,000, 4,000, then 1,000 and then 0. So I'm not writing the full things here. So I remember now I can see that this is 4183. So it is between 4,000 and 8,000. So anything above 10,000 is going to be ranked 1, anything between 8,000 and 10,000 is going to be ranked as 2, and anything between 4,000 and 8,000 will have a rank of 3. So that is how this rank is being computed. Similarly, for the other second record, this is the value 1863. So this lies here and it gets the rank 4. So what is the use of this? So this is a very powerful function. So we have seen that in the first scenario we can use it to compare the value in the cost function with the table itself. And now here we have another lookup table and we are using the value which is part of our reference table, and we are comparing it with a lookup table. The other two parameters are defined here. So I still haven't defined the last parameter. So this is the second last parameter, which if I do not even specify, is the default value of this is descending order. So here if I write DESC, or even if I do not write, then it actually means the same thing. But if I want to reverse the ranking, where I am kind of changing the sort order of comparison, then I can write ASC, which stands for ascending. The last parameter is for scenarios where you have a situation where the two values are identical. So in case you have two values which are identical, then you can decide that the ranking should either be a skip based ranking or a dense based ranking. So now let's go back to the dax.guide website and see how we define the skip and the dense ranks. So here you can see that this is the last parameter, this is the last optional parameter that we have, and you can find two words here, skip and dense. So what is skip? So skip ranking is that ranks correspond to elements in ties will be skipped, and dense means that all elements in a tie are counted as one. So if you have two numbers that have the same value, then based on this parameter, if you say that I want to skip that ranking, then in case of a tie, the ranking would be skipped and you would be going to the next one. And if in the case where you have defined dense, then all the elements in the tie are counted as a one value and there is no skip in the rank. So if I scroll down on the same dax.guide page, here you can see an example that clearly explains what is the skip rank and what is the dense rank. So here you can see that here we have two values that have the same number associated. So it is 3 million. So in case of a skip rank, you are going to see that both of these are assigned the rank 4 in terms of the ranking, but then the next rank is not 5, it is 6. So it is called the skip rank, so that the next ranking is skipped. So if you have two values, then one rank would be skipped. If you have three values, then two ranks would be skipped. So let's say if I come here in this area, then we have three values which have 100,000, 1 million as the value. So here 9 and 10 is skipped, and the next rank that you are going to see is 11. However, for the dense ranking, the ranking is not affected by how many ties are there. So you are going to get the same ranking as the next number, and you're not going to skip anything. So it would say 4, then 5, then 6 and 7. It does not matter that how many values are there inside the the area which have the same rank. So this is the last parameter that you define. So the default value for this, if you remember, is that it is, if you scroll up, then it says that the default value, if you do not specify anything, is the skip rank. And similarly, if we have seen that if you do not specify the order, then it is descending order. So this is an important function. Rank X is a very important function. Previously, this was the only function that was there to compute the ranking. But over the last 6 months or so, there is another function which is the rank function, which is very much similar to the rank function that we have in SQL. Now that function can be used to compute the ranking. And if you want to go and understand that function, is probably a bit easier to understand and easier to implement. So remember that rank X is an iterator function, and obviously here in this scenario we have used it inside a table function, but we can use it also inside a measure. And obviously there, that instead of the physical table, we can specify a virtual table. So the rank X function can be used inside a measure as well. So this was all about rank X function. Now we are going to look at the last function, which is concatenate X. So here we are on the dax.guide website, and we are having a look at the concatenate X definition. So the definition states that this function evaluates expressions for each row on the table and then returns the concatenation of those values in a single string result separated by the specified delimiter. So again, you can see that having an X at the very end means that this is an iterator function, and this function evaluates a given expression for each row on the table, and it returns the results by concatenate the values in the form of a single string result. So let's go to the Power BI environment and see how we can use the concatenate X function. It is similar to how the rank X worked, with having just the two parameters which are mandatory, and then there are a few of the optional parameters. So let's go and see how this concatenate X function can be used. So here I am inside the Power BI desktop environment, and here instead of now creating a table, I have created a measure, and I am starting off with the rank X function that we just discussed. And the measure actually has a rank X, the rank X DAX function, and then I have the regions table, and then the total cost measure. And I want to actually see that what is the ranking of my regions with respect to the total cost. So I want to actually see this inside a visualization. So what I have done here is that I have pulled up a simple visualization, and inside this visualization, as you can see, there is just the sales region and just the total cost. And now I want to just pull this thing here, which has my regions rank. So here you see that the rank is giving a value of 1 for all the regions. So we need to first understand, because initially we had a look at rank X within a table, but now we are having a look inside a visual, and the filter context is coming into play here. So what is actually happening, that once we are trying to compute the rank, this sales region inside the visualization is filtering the lookup table, and the only value that we see is the value of that particular row. So that is why it just comes and it just returns the value of rank, which is 1, and this happens for all the records. So somehow we would have to make sure that we get rid of the filter context, or we get rid of the filters, and we can easily do that through the all function. So let me just amend my measure and then have a look at this scenario again. So now what I have done is that I have done two things. So first of all, I have included the all table function here, and secondly, instead of the regions table, I have just put the sales regions column, because that is the column that is coming into the context in the visualization. So now let's go and run this, and once I run this, this is the result that I see. And clearly you can see that now this thing is working properly. So the highest value here is 342,000. So this is the first value in terms of the rank, then this one is the second one, and so on and so forth. And if I just want to see that in the within the visualization, I can use the sorting. So don't worry about this sorting. We are going to have a detailed look at the sorting here, but here you can clearly see that now the rank is working all right. So now let's go and see actually what actually happened behind the scenes, that why was the initial expression not working and why this expression is working. And in order to do that, what I'm going to do is that I'm going to just replace the rank x function with the concatenative x. So I've done here is that I have just replaced concatenate rank x with concatenate x, and now this is my table. And for my table, this is the value that I am going to have a look at. So initially I should expect to have some kind of a lookup table given to me for all my regions. So let's just run this and see what do I get. So here, if you see, we are getting some kind of a concatenated value, and this value is not readable because we haven't given the optional part of the concatenate x syntax. We haven't given the parameters that are optional, and those parameters are basically related to a delimiter that we want to give. And then if we want to do some kind of a sorting within the values, we can do that. But now you see that for all the values, we are actually getting some kind of a value. So now let's go and see what are the parameters that need to be given so that this kind of becomes understandable. So now I have come here and I have put another parameter, which is the delimiter that I want between the values. So remember, concatenate x is looking at this table, and now the filter context is no longer there. So what I would be getting is the value of total cost associated with all the regions. So this is what should I expect, and between these values I expect a comma. So now let's run this and see what do we get. So now you can see that the values here in all the records that we have are split by a comma value, and this is exactly the behavior that we expected, because now the filter context is no longer there, and this is the lookup table that is being evaluated behind the scenes. So remember, for the rank x, this is the lookup table that is created behind the scenes. But what is concatenate x doing here? It is actually helping us visualize what is actually happening. So the rank is not being computed here, but if we just have a look at it, we would understand that, okay, this is the kind of lookup table that is created with all these values. So you can see that this comma is kind of referring to as a delimiter. So we have the first value here, then the second value, and the third value, and the fourth value. So let's now replace this comma with a equivalent code which kind of puts the functionality that we see with the enter key on the keyboard. So we are going to see all of this in the new line. So now let's go and slightly modify our code. So here I have replaced the comma delimiter with this unicar function, and I have given the value 10, which is associated with the same functionality that we see for the enter key on our keyboard. So now let's go and run this and see what is the result that we get. So here now you have the lookup table kind field that we talked about a few minutes ago, and this is the lookup table that is there. So for every time. Remember that the rank X actually sorts this lookup table as well. So if you are coming and looking at this value, then this value would be there on the very top and would relate to the rank 1. So what we are doing here is that we started off with the rank X function, but in order to understand how the rank X function worked, we used this concatenate X function, which actually took that expression and computed everything that is happening behind the scene. So this is a very important function and it is very helpful once you are writing DAX. And if you are stuck somewhere in terms of debugging the DAX, then this concatenate X function can also help you. So there are other ways that this concatenate function is used, but this is one of the most easiest way or one of the most appropriate way to understand the working or functionality of this concatenate X function. So this brings to an end to this very long topic where we discussed in detail about the DAX table functions. So make sure that you are familiar with all these table functions and you are also able to understand what is the syntax, because on the exam you are most likely going to be examined on the syntax part only. So you should immediately recognize that, okay, if this is a scenario, then this is the function, or this is the function, then this is the syntax. So this is these are the two ways you can get any question on the exam. We are going to look at some of the practice questions where you would have further clarity on how these table functions can be used. So that's all for this video, and I will catch up with you in the next video.